This is a quick review for the test that largely covers Chapter 5 in our textbook that deals with quadrilaterals. Also contains 6.1 and 6.4 that deals with triangle inequality and finding the largest angle or side in the triangle based upon some measurements. So the key thing to remember are all the properties. So for quadrilaterals, if we have parallelograms, then we have rectangles, rhombus, and square. The further we go down this chart, the more specific the object. And we can use the sentence, every blank is a blank. As we go up this chart from the bottom to the top. It's true that anytime you have a more specific object, so here you can say every square is a rectangle, or every square is a rhombus, or every square is a parallelogram. This would be saying from a more specific to a more general, that's always going to be true. So for example, an item of clothing. Every t-shirt is an article of clothing. That would be true. In the other direction, it would be false. You couldn't say every item of clothing is a t-shirt. And then if we look at properties of parallelograms, this is where all the opposites come in. Remember, we have three that have the word both. So both pairs of, so number one, opposite sides are congruent. Both pairs of opposite angles are congruent. Both pairs of opposite sides are parallel. Another big one is the diagonals bisect each other. So by that, they're not the same length, but they bisect each other. And don't forget, angle A, and let's say angle D, consecutive angles are supplementary because they are same side and two angles. So A and B would also be supplementary up to 180. And in a rectangle versus a rhombus, well, they're both special parallelograms. So those properties above that we named are true for both of these shapes as well. But there are extra things. Diagonals are congruent in a rectangle, whereas the diagonals are perpendicular in a rhombus. In a rhombus, the diagonals are also lines of symmetry. So they, in fact, bisect each angle, each vertex angle. And of course, a rectangle has four right angles. But notice when we draw the diagonals, even though they are congruent, they are not perpendicular. But since diagonals bisect each other from a parallelogram, the key thing here to realize is all four of these little segments of the diagonals are congruent, and therefore you have an isosceles triangles. So realize, let's look at this bottom triangle. So realize, since this is an isosceles triangle, this base angle is equal to that base angle. Also realize we have alt interior angles. So this angle up here equals that angle, and so too would these angles be equal. So if we're given a measure in the diagram, if let's say this angle is known to be 50, that's all we're given. Well, of course, this angle has to be 40 because they're complementary. Well, if this is 40, then that angle has to be 40 because of isosceles triangles. We have alt interior angle. This is 40 and this is 40. This would be 50 and this would be 50 as well. And if you have two angles in a triangle, 40 and 40 is 80, so this is 100, and therefore you can actually find all of the angles in this polygon. I'm going to draw the rhombus page. So once again, if we have a rhombus, I would draw it long and skinny. A rhombus has 4 equal sides. And the key thing, as I mentioned, are the diagonals. They are perpendicular. They form right angles. The diagonals bisect each other, but the diagonals are not congruent. So here we have different side lengths, 2 markings and 3 markings. Here all 4 triangles are congruent. So if I give you, let's say, one angle, say 60 degrees, well, we have a right triangle. If you know 2 angles in a right triangle, you can find a third. So this angle would be 30, and now everything goes by folding. Don't forget lines of symmetry, so I can flip across the 60 here, the 30 down here, 30 next to it, 60, and the 60. So make sure you realize that as you solve problems relating to rhombuses. Next is a square. Well, a square is a special parallelogram and also a special rhombus and rectangle. So a square has all the properties of the aforementioned figures. The key thing is, like a rectangle, 4 right angles, like a rhombus, 4 equal sides. Like a rectangle, diagonals are congruent, so we have 4 equal segments. Like a rhombus, they are perpendicular. We have 4 right angles, and also like a rhombus, the diagonals bisect the angles. So therefore, in a 90-degree angle, this is going to be 45, this is going to be 45. Unlike a rectangle, those are not bisected. That means each of those angles where these dots are, all are 45 degrees. So these are all isosceles right triangles. And one thing to just go back about parallelograms. We know if any of the 4 properties are true, that the object is a parallelogram. Say, for example, if the opposite angles are equal, if I just give you a quadrilateral with that, we know it must be a parallelogram. And that's true with the other 3 properties. But another one to prove, if a quadrilateral is a parallelogram, if I give you one pair of opposite sides parallel, and that same pair of opposite sides are equal, that must be a parallelogram. That gets us to some other theorems in this section. If you have 3 or more lines that are parallel, and if you have some transversal that is cut into congruent pieces, then any other transversal, no matter how it's drawn, is also divided into congruent segments. Just be careful with questions like this. That's point A. If this is point B, if this is point C, just be clear to read. If I give you AB as some algebraic expression and BC as some algebraic expression, of course equally you'd set them equal. But be careful, if I give you AB as some algebraic expression and AC as some algebraic expression, you would not want to set them equal because AC is longer. In fact, it's twice as long, so you'd have to do 2 of the smaller piece, AB equals 1 AC. So just watch out for that. Then we have the theorem that I call the triangle midpoint connector theorem. So in any triangle, if you connect the midpoint of 2 sides in a triangle, and if you draw in the new segment, there are two things that are true about this new segment. So this green segment, it's parallel to the third side of the triangle we didn't touch, and it's half the length. So AB compared to CD. AB, the new segment, is going to be parallel to CD, and this new segment is also going to be half the length of CD. So if it was numerical value, if CD was 12, half of 12 is 6, so therefore AB would 6. If it was an algebraic expression for AB and CD, you would use that formula as well. Or of course you could say 2 of the small ones equals just 1 of the large one. And something related to this, if I give you a triangle, and if I give you a midpoint, and if a line segment goes through that midpoint to the other side, and if we know that it's parallel to that third side, then it must go through the midpoint of the other side. So if we have AB, and point M is the midpoint of side AB, if we draw a line through point M, that's parallel to the other side BC, what our conclusion is, we can conclude that AR equals RC, making R the midpoint of line segment AC. Not used too often, but you should possibly know that. Another theorem which you need to know, if you have a right triangle, of course, is a triangle with a right angle. If you go to the hypotenuse, which is the longest side across the right angle, and if you find the midpoint, theorem is that midpoint, in this case, point M, is equidistant from all three vertices. So it's equidistant from AC and also from B. So if I give you a right triangle, if someone gives you a right triangle, that's the case, you must realize that. Other things to look for, so outside of length, so if I give you this length is 26, then you would have to realize, of course, that these smaller segments, we have 3 equal segments, all of 13. What if I give you an angle? Suppose this angle down here is 60 degrees. What can we find? Well, since it's a right angle, angle B is a right angle. If that's 60, this must be 30 degrees. And then more than that, we get back to our isosceles triangles. This triangle here, there are 2 equal sides. It's isosceles, so the base angles are equal. That means you know this angle is 60, and now you're able to find everything in the triangle. If 2 angles are 60, that's 120. This is 60. A linear pair, this one is 120. And then this top triangle in green with these 2 equal sides, it's isosceles, so the base angles are equal, so that's 30. Or another way to have looked at that is this big triangle. Well, that big triangle, 3 angles is the right triangle, so there's 90. If this angle is 60, that means the remaining angle of the big triangle must be 30. Already made on trapezoids, that was in 5.5, so a trapezoid is a quadrilateral with exactly, it's only one pair of opposite sides parallel. And then we had a theorem about the median, somewhat similar to the triangle midpoint connector theorem. So the median is the line segment that goes to the midpoint of the 2 legs. The bases are the base is the parallel sides. The other 2 sides are called the legs. So this segment that goes to the midpoint of the leg, so this is one leg, the other leg on the other side, then on parallel sides. The theorem is the median is the average of the bases. Well, average is adding 2 numbers and dividing by 2. Or by cross multiplying, we can say 2 medians, once again with M in the equation is the median, and B1 and B2 represent the bases. Doesn't matter which base is used to be B1 and B2 in the formula. So if we cross multiply that first equation, we get 2m's, 2 medians, equals the sum of the bases. This will help you with both algebraic and numeric values. Once again, this m formula represents the average of the bases. And then 6.1 was the triangle inequality theorem. So if you have an exterior angle in the triangle, call that angle 1. If you remember, this is a review of the old theorem, the extra angle theorem. The extra angle in a triangle, the angle outside, is equal to the sum of the two remote interior angles. Well, since all angles are positive, if you add two positive numbers, the result is going to be a larger number. So the extra angle inequality theorem states the exterior angle, in this case angle 1, is greater than either remote interior angle. Let me fix this. The exterior angle, angle 1, is greater than either remote exterior angle. So angle 1 must be bigger than angle 2 in this diagram, and angle 1 is also larger than angle 3. So if I just gave you the exterior angle, if the measure was 121 degrees, what can we conclude? Well, other than saying 2 plus 3 must equal 21, by the exterior angle inequality theorem, we could just say that the 121 degrees is larger than angle 2, and 121 degrees is larger than angle 3. So angle 2 and angle 3 must each be less than 121 degrees. And the last part of this quick review for your test, section 6.4 deals with find the largest angle and side in the triangle based upon the measures. If I give you 3 sides, really easy. The longest side is across from the largest angle. So since BC has a side length of 6, the longest side, so therefore the largest angle is across from it. So angle A would be the largest angle. It has the angle with the biggest measure. And the other part of the theorem is across from the smallest side. Well, 4 is the smallest side, is the smallest angle. So in this case, angle 6 is the smallest angle. So if I give you a triangle with angle measures, typically you may only be given 2 angle measures. So if I give you 7 degrees, and these are not drawn to scale, and 60 degrees, if I ask what's the longest side or the shortest side, well, you need to find the measure of the third angle. So 180 degrees are in a triangle, so therefore this is 50. So therefore the longest side is opposite the largest angle. So we look for the largest angle, which is 70 degrees. So the longest side is side DF, and the shortest side is going to be the one opposite the smallest angle. The smallest angle is 50, so therefore DE. You look at my video for 2 triangles that intersect. You cannot, if I give you angle measures, you cannot just look at the smallest angle and assume that the shortest side is across from that when 2 triangles overlap. I encourage you to go back at the video that I made from section 6.4 that goes in more detail over how to solve problems like that. And the last 2 things are, if I give you 3 sides in a triangle, is it possible to form a triangle? So if I give you 3, 4, and 6 versus 3, 4, and 5 versus 6, 11, and 4. The easiest way to do this is the small side, is the sum of the 2 smaller sides bigger than the longest side? So you check to make sure your numbers are small to large. So is 3 plus 4 greater than 6? I put a question mark. Of course, 7 is bigger than 6, so if it's yes, easy way to remember it, that means yes, a triangle can be formed. So if I do 3, 4, 5, the sides are in order from small to big. So does 3 plus 4, question mark, is that bigger than 5? 7 is bigger than 5, so yes, a triangle is formed. This one, be careful. 6, 11, and 4 is not in order from small to big, so you can get a false positive, so to speak. If you did 6 plus 11 is 17 is bigger than 4, you'd say yes, but that'd be incorrect, because if you reorder your numbers from small to large, you get 4, 6, and 11, and if we apply the same rule, do some of those two small ones, in this case 10, is that bigger than 11? The answer is no. That means no triangle is possible. Lastly, if I give you two sides in a triangle, and I ask you to find the length of the third side. Well, it's a little tricky to fully go over because that missing side could be the smallest of the sides, it could be the middle side, or the longest side. But the easy way to do it is the third side must be in between two numbers. You simply have to add the two numbers up. 8 plus 3 is 11. And you subtract your sides. 8 minus 3 is 5. So therefore your third side of the triangle must be between 5 and 11. Because let's just check if it was 3, 5, 8. So the 8 would be the largest side if it's 5. Well, 3 plus 5 is not bigger than 8. But if we said the third side has to be bigger than 5, so 3 plus 5.01 is indeed bigger than 8. So that's possible. And so too, if it's 11, we're saying 11 is the longest side. If it has to be less than 11, 3 plus 8 is 11. So if it's less than 11, like 10.999, then 11 is bigger than 10.9, it would work. Once again, all you have to do, if they give you 17 and 47, the third side has to be in between two numbers. The easy way to do it is write it like this. So it's in between, you add them up. So 47 and 17 is 64, and you subtract them. 47 minus 17 is 30. That third side, therefore, is between 30 and 64. Okay, study and look at the other videos and your review and your notes. And good luck.